how to expand this determinant. This we call expansion of a determinant. Even before doing, I could have said the answer is 0. How? Look at first row and second row. First row is 1, 2, 3 and second row is 2, 4, 6. See 1 into 2, 2 into 2, 3 into 2. So I will say row 1, R1 tells me row 1 and R2 tells me row 2. These two are proportional. What do you mean by the word proportional? First row, I multiply by a number, I get second row. Such ideas we call proportional. Whenever two rows are proportional, I need not do all this. I can immediately write the answer 0. See, expanding is easy or identifying this is easy. Definitely this idea. So, it needs to know the properties of determinants. Without expanding, can I simplify it easily? So, here are the list of properties. Matrix A and matrix A transpose have the same determinant. Matrix A and matrix A transpose has the same determinant. Determinants of A and A transpose are equal. So this tells me if I interchange rows and columns of a matrix, determinant value does not change. Look at these two determinants. 1, 2, 3, 1, 2, 3. 4, 5, 7. Here it is second row, but here I have written as third row. 12, 0, minus 1. Here I have written third row, whereas here I have done second row. So what have I done? I have interchanged R2 and R3. R2 is second row. R3 is third row. When I interchange two rows, my answer becomes negative. So whatever answer comes for this, change the symbol when I do this operation. So this, suppose this answer is 30. This answer will be minus 30. Suppose this answer is minus 12. This answer will be plus 12. So what I do? Interchanging two rows, my answer becomes negative. So this is the second property. Can I interchange two columns? Yes. So when you do interchanging C1 to C3 or C1 to C2 or R1 to R3. So all these ideas tell me interchanging two. You cannot interchange column and row. You can interchange columns or rows. And if you do, whatever answer was before will now change the symbol. So here plus 10, I get minus 10 here. Here minus 10, I get plus 10 here. So this is a very important idea in determinants. What is the answer for this determinant? Row 1 and row 3 are identical. Row 1 and row 3 are identical. I need not expand. Immediately put the answer 0. So in all the exercise problems, this is our first idea. Given a determinant, check whether any two rows are identical. And once I decide they are identical, immediately put the answer 0. Give me another example. 407. 407. Whatever comes here, X, Y, Z, any number comes here, I don't bother. What is my answer? 0. Because column 1 identical to column 2. X, Y, Z may be any numbers. I don't bother. Even 1000, 3000, 1 crore, anything can come. Column 1, column 2 are identical. Immediately put the answer as 0. When I see the first row, is there any number common? Yes, 2 is common for all the first row elements alone. Take 2 out. What remains? 1, 2, 3. If I take 2 out, 1 times 2, 2 times 2, 3 times 2. This is another property of determinants. A particular row, a number is common. I can keep it out. Write the remaining in. Second row, third row, no change. So this is my first step. And the previous property says, two rows are identical. My answer is 0. So this I will write 2 into 0. So it is 0. So what do I infer? Two rows are proportional. Even now, this symbol we call proportional. Proportional means multiples. 1 2s are, 2 2s are, 3 2s are. Even now, my answer is 0. Give another example. 5, 10, 15. 1, 7, 0, 4, minus 1, 3. Which number is common in first row? 5. So I can take 5 out. It becomes 1 5s are, 2 5s are, 3 5s are. 1, 7, 0, 4, minus 1, 3. So here I have to expand and find the answer. Here I am able to say immediately. Now nothing is identical. So I have to expand, putting plus minus all that. So here what we mainly say, any number common for a particular row, take it out. So 5 is taken. This becomes 1, 2, 3. Second row and third row, write as it is. Look at this example. X, Y, Z, Y, Z, X, Z, X, Y. Is there anything common? No. Is there anything identical? No. But can you make something as common? You can. Add row 1, row 2, row 3. See what happens? R1 plus R2 plus R3. Put this new thing in an R row, R1 or R2 or R3. So R1 becomes, add R1, R2, R3. Add and tell me. X plus Y plus Z. Y plus Z plus X. Z plus X plus Y. So what have I done? Adding first row, second row, third row, and I am putting it in R1. So R1 becomes, when I write, it should start with R1. I cannot say R1 becomes R2 plus R3. I should write to R1, I can add another row or I can subtract another row. Whatever is needed, I can do. We can also write R1 becomes R1 plus 2 times R2, 3 times R3. So these are another way of easing our answer. So when I add like this, my answer becomes simple. I can very well do it. So this is an important property in determinants. To any row, I can add or even subtract equi-multiples. Second row fully I multiply by 2. Third row fully I multiply by 3. I add or subtract according to my need. I should not write R1 into R2, wrong. I should not write R1 divide by R3, wrong. I can add or subtract. If I need, I can multiply by a number. Scalar multiplication allowed. But I should not multiply or divide. So in this case, by adding R1, R2, R3, I get first row as X plus Y plus Z throughout. Second row, no change. Third row, no change. Now this helps me. First row, X plus Y plus Z is common. If I take it out, I get 1, 1, 1. Second row, Y, Z, X, no change. Third row, Z, X, Y. Now I have to expand and proceed. Most of the problems try to bring ones in the determinant. So this idea tells me I can subtract. So 1 minus 1 will yield 0. Easy for us to expand. So these ideas will be understood when we do the exercise problems. Next property. First row alone has two elements. Sum of two elements. Second row, third row, it is only single element. How shall I simplify? Put the determinant itself as sum of two determinants. All the first elements write in the first determinant x, y, z. All the second elements put in the second determinant y, z, x. Second row, third row, no change. Write as it is. So what is second row? Y, z, x. Here also y, z, x. What is third row? Z, x, y. Here also z, x, y. Now you proceed with the problem. So this is another important property in determinants. First row is a sum of two elements. So the determinant itself is becoming sum of two determinants. First row, all the first elements will come in the first determinant. All the second elements will come in the second determinant. Second row, copy the same. Third row, copy the same. The proofs are not needed, but the properties you must be thorough with. So in every problem in the exercise, we will highlight the properties once again. Example 1.9, mostly repeated 5-mark question. We start with LHS. First thing I check whether any rows are identical. No. If A, B, B, C, C, A are there, I can multiply by A, B, C. No such idea. So the next clue is ones. Whenever ones are there in the determinant, try to subtract. See, R1 becomes R1 minus R2. How we do it? R1 becomes R1 minus R2. So hide it. 1 minus 1, 0. A minus B, write as it is. A square minus B square. The same idea, R2 becomes R2 minus R3. See, remember, if I write R1, my answer should start with R1. If I write R2, I should start with R2. I mustn't write R3 minus R2. So, subtract. 1 minus 1, 0. B minus C, write as it is. B square minus C square, write as it is. Third row, copy as it is. Now, A square minus B square. How can we factorize? It's algebraic formula. A square minus B square is A plus B into A minus B. Similarly, the second row, B square minus C square can be written as B plus C into B minus C. Write third row as it is. Now we are going to apply the property of the determinants. What does the property say? If anything is common, any term, any number, I can take it out. A minus B, from 0, I can take any number out. So in all the three, take A minus B out. Similarly, second row, B minus C is common, take B minus C out. So first row, what remains? 0. A minus B I have taken, this will become 1. A minus B I have taken. What is remaining? A plus B. In the second row, B minus C is taken. So what is left out? 0, 1. B minus C is taken. What is remaining? B plus C. Copy third row as it is. The next step, we shall expand. Here there are more zeros, so expand along column 1. What are the symbols for column 1? Plus, minus, plus. Remember, this is 1 plus 1, 2. Even number, positive. Odd number, negative. Even number, positive. So I am going to expand it. We have A minus B, B minus C, which is out. copy as it is. Here 0 into anything 0, 0 into anything 0, only 1 is left out. So 1 into, hide the row and column, we are left with 1 into 1 A plus B, 1 B plus C. This is equal to A minus B, B minus C into multiply, subtract. 1 into B plus C, B plus C minus 1 into A plus B, A plus B. As I am subtracting A minus B, B minus C as it is, since I am subtracting, B and B will get cancelled. I am left with C minus A, and this is the RHS. So we started with LHS and we have arrived at the RHS. What are the properties we have used? R1 becomes R1 minus R2. R2 becomes R2 minus R3. Take common term out. A minus B, B minus C common from row 1 and row 2. When I expand 0 into anything 0, need not write it. Again 0 into anything, need not write it. Only 1 left out. Hide the row and column. Write this here and we have expanded. Multiply 1 into B plus C. Multiply 1 into A plus B. In between minus. As I subtract, B and B will get cancelled and we arrive at the RHS. Question number 8. Prove that minus A square AB AC, AB minus B square BC, AC BC minus C square. So let us start with LHS. Minus A square AB AC, AB minus B square BC, AC BC minus C square. First row A is common. Let us take it out. By the property of determinants, first row A is common. Second row B is common. Third row C is common. So we take A from first row, B from second row and C from third row. What is left out? I am taking A out minus A. A is taken B. A is taken C. Second row B is taken A. B is taken minus B. B is taken C. Third row C is taken. A left out. C is taken. B left out. C is taken. Minus C left out. Now I can see here A, here minus A. So R1 becomes R1 plus R2. So that A minus A will become 0. B minus B. R1 plus R2 means add like this. A minus A 0. B minus B 0. C plus C will give me 2C. Similarly, add R2 with R3. We are adding R2 and R3. So forget the first row. I am adding these two. A plus A 2A. Minus B plus B 0. C minus C 0. Third row write as it is. At a time do the transformation only for 2 rows. Don't do for all the 3. The next step we shall expand. We have A, B, C out. Remember how to expand the determinant. Plus, minus, plus. 0 into anything 0. 0 into anything 0. So forget it. Only 2C left out. If I take 2C, hide the row, hide the column. What is left out? 2A, 0, A, B. Find out the answer. This is equals A, B, C. 2C is there. When I expand the determinant, 2AB minus 0 into A is 0. So we are left with 2 into 2, 4. A into A square B into B, B square, and C into C, C square. This is the RHS. Exercise 1.1, question number 7. Prove that we are given a determinant and we want to show it is 0. Take the LHS, we will try to achieve the RHS. LHS equal to 1 by A, BC, B plus C. 1 by B, CA, C plus A. 1 by C, AB, A plus B. Remember to put straight lines. These are notations for a determinant. Now, BC, which letter is missing? A. Here C, A, B is missing. Here A, B, C is missing. This is how we identify the clue to do the problem. A is missing. So R1, this is row 1, multiply by A. So we write R1 multiply by A. Similarly, R2, B is missing, multiply by B. R3, C is missing, multiply by C. And whenever I multiply, I should also divide by ABC. So we write 1 by ABC. I am dividing by ABC, put it out. R1 multiply by A by A is 1. A into BC, ABC. A into B plus A into C. Second row, multiply by B. B into 1 by B is 1. B into CA is ABC. B into C, BC plus B into A, BA. Third row, multiply by C. C into 1 by C, 1. AB into C, ABC. C into A, AC. C into B, BC. Now, in second column, there is a same element ABC, 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 which is common. So, any common element can be taken out. So, my next step is taking ABC out from C2. ABC by ABC, first column copy as it is. If I take ABC out, this is 1, 1, 1. Third column copy as it is. Now what is my answer? ABC, ABC cancels and my answer is 0. Why do I say my answer is 0? Because column 1 and column 2 are identical. So we write it here. C1 identical to C2. It's a property in a determinant. Whenever two columns are identical, my answer is 0. And 0 is the RHS. So we started with LHS and we have ended with RHS. Hence the problem. Exercise 1.1, question number 6. Evaluate. Now we are going to apply properties of determinants. There are two terms in column 3. So the determinant itself will become two determinants. So this is the question given. Which is equal to sum of, or I will say there is minus symbol, so minus two determinants. First column, no change, write as it is. Second column, no change, write as it is. Third column, all the first elements in first determinant, so A square, B square, C square. Then all the second elements in the second determinant. We will put plus here, put minus BC, minus CA, minus AB. So when one particular column is expressed as a sum of two elements, determinant itself is becoming sum of two determinants. First and second column, no change. Write as it is. Third column, all the first elements in first determinant and all the second elements in the second determinant. Now, we learned if a number is common, I can bring it out. So here minus symbol is common in C3. C3 means column 3. Take minus symbol out. So my next step is 1a square, 1b square, 1c square. Taking minus symbol from column 3, 1 1 1, ABC, BC, CA, AB. Now I want to simplify the answer by taking something common. Here BC is coming, A is missing. Here CA is coming, B is missing. Here AB is coming, C is missing. So first determinant, let us write as it is 1a square, 1b square, 1c square. Minus symbol also as it is. Take the second determinant alone separately. Simplify the answer. Consider. What is the second determinant? 1a BC, 1b CA, 1c AB. Row 1, A is missing, multiply by A. Row 2, B is missing, multiply by B. Row 3, C is missing, multiply by C. Whenever I multiply, I should divide by that. So divide by A, divide by B, divide by C. So this is equal to 1 by A, B, C. I am dividing. So write that A, B, C out. First column as it is, I am multiplying by A. So R1, every term multiply by A. 1 into A into A square, A into BC, ABC. Second row multiply by B. 1 into B into B square, B into CA, ABC. Third row multiply by C. 1 into C into C square, AB into C, ABC. Now in third column, property of determinant says a particular term is common, I can bring it out. So ABC is common, take ABC out. What is remaining? First column, no change. Second column, no change. Third column, I am bringing ABC out. One time. This ABC, I can cancel. The next step, interchange. I want to bring this model. Here I have 1a square. So, interchange C1 and C3. And we learnt a property. Whenever I interchange, symbol changes. So this determinant, I put minus symbol. C1 and C3 interchange. So here I get 1 1 1. Here I get ABC. The middle column, no change, write as it is. The next step, compare these two. I want ABC as the second column. So, interchange C2 and C3. Interchanging C2 and C3 will give a minus sign. There is already a minus, so it will become plus. 1 1 1. Column 1, there is no change. Column 2 and 3 interchange. So, I get A, B, C, A square, B square, C square. So we started with the second determinant and I have arrived at 1a square, 1b square and 1c square. So this we have done separately. Drop a line and now use this here. So the second determinant which I derived as 1a square, 1b square, 1c square. this is equal to same determinant but minus symbol will give me the answer 0. So the given problem, the value is reduced as 0.